Now we will look into rugged board general purpose input output. How to configure that general purpose input output as an input or an output pin. So before configuring that, let us try to understand some concepts. So in the rugged board A5D2X, the SOC is SAM A5D27. So SAM A5D2 A5D27 pin numbers versus GPIO port numbers. As you seen in the table, the SAM A5D27 pin numbers are listed from 0 to 127. But if we consider as a port numbers, it is given it as something like port A, port B, port C, and port D. So 0 to 31, port A, port PA0 to PA31 is port A, and 30 to 63 is represented as PB0 to PB31 is another port. So likewise port C and port D. So how we can calculate the SAM A5D2 pin number from the port number? Okay, so this we want to understand to configure the GPIO rugged board A5D2X GPIO pins. So the question is how to calculate SAM A5D27 pin number using GPIO port numbers. So if they give PC13, how do we calculate its corresponding SAM A5D2 pin numbers? So for that we will keep that port A as 0, port B as 1, port C as 2, and port D as 3. Okay, so this is where the port values we will be keeping it. And to calculate the SAM A5D2 pin number, we have to use this formula. Just it is going to be 32 into Px, where x takes the value A, B, C, or D. This is nothing but the ports, and GPIO Px number, that is the GPIO pin number. So this we will understand through one example. For PC13, SAM A5D2 pin number is 77. How we got this? Since it is a port C, since it is a PC, so 32 into PC plus, since this GPIO Px number is 13, we are adding it 13. So 32 into PC plus 13. What is this PC value? PC value is 2. So 32 into 2 plus 13, which gives us 77. So this is where the simple calculation. So likewise, you can calculate it for PD12, PB12, PA30. So using this thing, you will be able to calculate it. So once we understand this concept, let us try to have a look into the onboard LED circuit. In the rugged board A5D2X, there is a 3 LED circuits. Actually, there is a 3 LED, user LED is there. That 3 user LEDs are connected to PC13, PC17, and PC19. These all are GPIO in the port C. So in order to access this onboard LED, we want to export this PC13 or PC17 or PC19 by using the SAM A5D2 pin number. Okay, so in order to access this PC13, that is these pins PC13, PC17, and PC19, we want to export through this SAM A5D2 pin number. We need the pin number to export this port numbers. Okay, so that we will see in the next slide. So accessing the GPIO using the sysfs. See, this sysfs is a pseudo file system for all the devices, drivers. It will be creating one device files in this sysfs class directory. You will be getting most of that. All the drivers are represented in this directory. That is the way followed in the Linux. So for example, for us, let us consider PC13. So since PC13 is connected to our user LED, we want to configure it as an output pin. Why? LED is an output device. So we want to configure PC13 as an output pin. So how do we do it? Okay, in the terminal, we will be echoing this 77 is nothing but SAM A5D2 pin number. SAM A5D2X, this pin number, that is going to be 77. By using this formula, we calculated that PC13. So PC13 is the SAM AFI due to pin number is 77, that we are exporting through sys class GPIO. I told you, no, sys class, inside you will be having a GPIO, and there you will be having export. So we are exporting, that is we are exporting the 77 in this export file. So that means once after running this command, PC13 folder will be generated in the GPIO folder. Under GPIO folder, PC13 folder will be generated. That means that PC13 pin has been exported. That is the meaning of that. Then after exporting, we want to make that pin direction as an output pin direction. For that, echo, we have to give out, and we are redirecting that into the sys class GPIO. Since after export, PC13 has been exported, and inside that there is a file called direction. In that we are writing out. So we are configuring that PC13 as an output pin. Then once we configure as an output pin, then we want to write the value. For that, we are using this echo. 0 is exported to sys class GPIO PC13 value. Once 0 has been written inside this value file, the GPIO LED will be glowing. Why? Because since this is connected as an pull up resistor. So when this PC13 is something given as 1, means it is being having a voltage, so there is no flow of current. So once we make this as 0, there will be a flow of current, so the LED will glow. So that is the idea. So when we make 0, that the PC13, the corresponding LED will be glowing up. When we make it 1, the corresponding LED will be off. So by using these things, we will be able to toggle 0 or 1. If we write it, we will be able to toggle or blink that LED. Then if we want to unexport it, so the same echo 77, redirecting it to sys class GPIO. There is a file called unexport. If we write that inside that unexport file, so the GPIO PC13, that the directory will be getting vanished, or something, it will be getting unexposed. So this is what the basic concept. So using this as a base, we need to write an C program how to make this LED on off by automatically. Okay, so this is, since this is something like a file, so it is we will be using open, read, write, and close system calls. So this is write a C program to blink the LED connected to the PC13, PC17, or PC19. So I will be showing a practical session on this by using by making any one of the pin as an output pin, and we will try to blink the LED.